this video is going to cover Module 2, Homework 6 notes, talking about polynomial functions. It says identify each term, 5x squared plus 2x minus 8. And it says note, terms are separated by addition and subtraction. So 5x squared is its own term, positive 2x is its own term, and then negative 8 is its own term. So we have three terms here. So a polynomial contains many terms with positive whole exponents. The degree is the sum of the exponents on the leading term. The leading term is a term with the largest exponents, and a coefficient is the number in front that's being multiplied by the variables. So it says identify the, given the polynomial, identify the coefficients and the degree of each term. What is the leading coefficient? What is the degree of the leading term? What is the degree of the polynomial? So a couple things. So the leading term, remember, is the term with the largest exponents. The term with the largest exponents. The leading coefficient is the number in front of the leading term. The degree of the leading polynomial is adding up our sum of the exponents. On leading term. Sum of the exponents on the leading term. And then the degree of the polynomial would be the degree of the leading term. So the degree of the polynomial is the same. All right, so let's do this example. Oops, let me see. So the leading term, well, here we have -4. So -4 is the only term, so it's going to be the leading term. The leading coefficient is the number out front. Well, the number out front is just -4. So the leading term is -4, the leading coefficient is -4. What is the degree? Sum of the exponents. There are no exponents because there's no variables. So this is the same thing as saying x is 0 because there's 0 x's. So the sum of the exponents would just be 0. And that means the degree of the polynomial would also be 0. It's kind of a funny one. So same thing for example 2. -4 plus 3x to the 5th minus 5x cubed plus 4x to the 6th power. So what term has the highest exponent? Is 4x to the 6th power. So that's going to be our term with the highest exponent. That's going to be our leading term, 4x to the 6th power. The leading coefficient is the number in front of this leading term. So the number in front of 4x to the 6th power is 4. The degree of this leading term, the exponent of this leading term, would be positive 6. Therefore, the degree of the polynomial is also 6. All right, let's go to the next page. So which of the following are polynomials? So if you go back real quick, a polynomial has positive whole exponents. So which one of these have positive whole exponents? So 4x minus 8 plus 2 over x. This x is in the bottom. Remember, when things go to the bottom, going back to our properties of exponents, that is like negative, and the bottom means a negative exponent. So 2x to the -1 power. So because we have a negative exponent, it is not a polynomial. Remember, polynomials have whole, positive exponents. So next one, 4x to the negative 2 power minus 8x to the negative 1 power plus 2. Again, negative exponents, so not a polynomial. So same as up here. Next, I have 1/4 x squared plus 8. I have a positive whole exponent of 2, so that works. So yes is the polynomial. So this one works. So yes, polynomial. Next, we have 4x squared minus 8x plus 2. Again, positive whole numbers for exponents. I have 2 and I have positive 1. So yes is the polynomial. And lastly, I have 4x minus 8 square root of x plus 2. Because of this square root, that's not a whole positive exponent. So it's a radical. So not a polynomial. So only these two would be our answer. So next example, adding and subtracting polynomials. So simplify the expression by subtracting the polynomials. X squared minus 2x minus 8 minus negative 2x squared plus 3x minus 7. We want to distribute. There's nothing besides a positive 1 outside the first set of parentheses to distribute. So it's going to stay x squared minus 2x minus 8. Next, let's distribute this negative. So we're going to distribute that negative to every single term inside of the parentheses. So negative times a negative is positive 2x squared. Negative times a positive is negative 3x. Negative times a negative is a positive 7. So we're going to distribute. Next, we're going to combine some like terms. So we have, use a different color, x squared plus 2x squared, which will give us 3x squared. If you need to write that little 1 out front of x squared, go for it. So 1x squared plus 2x squared is 3x squared. Next, we have negative 2x minus 3x. So negative 2x minus 3x should give us negative 5x. Last but not least, 8. So we have negative 8 plus 7. Negative 8 plus 7 should give us negative 1. So we combine all of our like terms, we are done. Our final answer is 3x squared minus 5x minus 1. Same thing for the next one. Simplify the expression by adding or subtracting the polynomials. 10z cubed plus 2z squared plus 6z plus 2 plus 5z cubed minus 6z squared plus 6z minus 3 plus negative 9z cubed minus 10z squared plus 2z plus 1. Again, there's nothing outside of this first set of parentheses to distribute besides a positive 1. So it's going to stay 10z cubed plus 2z squared plus 6z plus 2. Again, there's nothing to distribute, but I can show it. Besides that positive 1 outside the second set of parentheses, whenever you distribute a positive 1, it's going to stay. Plus 5z cubed minus 6z squared plus 6z minus 3. Same thing for the last one. Let's distribute this positive 1. Whenever you distribute a positive 1, it's going to stay the same. So it will stay negative 9z cubed minus 10z squared plus 2z plus 1. So I got rid of my parentheses. Next, let's combine some like terms. So we have negative 10z cubed plus, I don't think I said negative. We have 10z cubed plus 5z cubed minus 9z cubed. So we have 10 plus 5 minus 9, which would give us positive 6. So 6z cubed. Next we have 2z squared minus 6z squared minus 10z squared. So we have 2 minus 6 minus 10, and that will give us negative 14z squared. Next we have 6z plus 6z plus 2z. So 6z plus 6z plus 2z, which would give us 14z. And then we have, last but not least, 2 minus 3 plus 1. So 2 minus 3 plus 1 will give us 0. So I don't need to write plus 0. I mean, if you cancel plus 0, so we don't need that one. So we have 6z cubed minus 14z squared plus 14z as our final answer. All right, next page. Last two examples. So simplify the expression by combining like terms, leave coefficients as reduced fractions. So 1 over 12 x to the fourth minus 1/4 x squared plus 7 minus 1/6 x to the fourth minus 1 over 2x squared plus 1 over 8. So I need to combine some like terms here. I can't multiply to get rid of the fraction because there's no equal sign. It's not an equation. I don't have two sides of the equation to keep it balanced. So we're just going to combine like terms here. So we use this is the combine like terms. All right. So I have 1/12 x to the fourth minus 1/6 x to the fourth. So side note, I have 1/12 minus 1/6. I need to get a common denominator. My denominator here would be 12. So I can multiply the top and the bottom of this equation by 2. And that would give me 1/12 minus 2/12. 1/6 becomes 2/12. So now they're like terms. 1/12 minus 2/12. 1 minus 2 would give me negative 1/12. So I have negative 1 over 12 x to the fourth. All right, next one. I have negative 1/4 x squared minus 1/2 x squared. So side note, negative 1/4 minus 1/2. I need to get a common denominator. My denominator here would be 4. My LCD would be 4. First one's already 4, so that's good to go. Second fraction, I can multiply the top and the bottom by 2 to make that into fourths. So if we have negative 1/4 minus 1/2 will turn into 2/4. So negative 1/4 minus 2/4 would give us negative 3/4. So we have negative 3 over 4 x squared. And then last but not least, we have 7 plus 1/8. So 7 plus 1 over 8. 7 is the same thing as saying 7 over 1. That way we can look at our denominators. I want to get a common denominator, which in this case would be 8. So I can multiply the top and the bottom by 8. So that means 7 would turn into 7 times 8, which is 56 over 8. 56 over 8 is still 7. We're just making it like terms. So 56 over 8 plus 1 over 8. 56 eighths plus 1/8 would give us 57 eighths. So plus 57 over 8. We combine our like terms, so we're done. So negative 1/12 x to the fourth minus 3/4 x squared plus 57 over 8. Last but not least, find the perimeter. Remember, perimeter means add up all the sides of the triangle. So add all sides. So we have negative x squared plus 9x plus 2x squared plus 5 plus 7x plus 3 is adding up our sides. There's nothing besides a positive 1 outside this first set of parentheses to distribute, so it'll stay negative x squared plus 9x. Likewise, there's nothing besides this positive 1 to distribute, but if I distribute just to stay consistent, a positive 1 It'll give us positive 2x squared plus 5. Likewise, distributing this positive 1, it'll stay plus 7x plus 3. So now we can combine some like terms. So we have, let me use it for negative x squared plus 2x squared. So negative 1 x squared plus 2x squared would give us positive 1x squared. Negative 1 plus 2 is positive 1. Next we have 9x plus 7x, which would give us 16x. So positive 16x. And then last but not least, we have 5 plus 3, which would give us positive 8. So I have x squared plus 16x plus 8, and then inches. Everything's in inches would be our perimeter. So that's it. So that is all of Module 2 Homework 6. You can now do Module 2 Homework 6. Module 2 Homework 6. You can now do Module 2 Homework 6, the homework assignment. If you have any questions, please let me know. If not, thank you so much for watching.